I'm Steven. I'm on GitHub and Twitter. And I'm going to talk about some things. I'm going to give you an intro, go over some use cases, talk about some of the pitfalls of using async iterators, and then do a little bit of just performance analysis. So if you haven't used async iterators before, it looks like this. It's a combination of generators and async await. So you have a function signature that kind of combines the async keyword and the little asterisks from generators. And you just have awaits and yields, just like async functions and generators. If you're not familiar with generators, rather than returning a single value, it returns an object that has a next function, and each time you call that, it gives you whatever is yielded. So you can yield a bunch of things. And yeah, it returns an iterator object that you can just use with the for await loop. A regular iterator you just use with a regular for loop. But this example will just at like every second just give you the current time, and you can just loop over time. And customer the async iterator is just like an interface. It's an object that has a next function which returns a promise, and that promise should resolve to this form of object has like whatever the current value is and a done flag, and when it's done, you can't return value or it just won't understand it properly. So you need to make sure you emit a separate done object at the end. And there's this symbol async iterator is what lets for await work. If an object has that on it, then you can just pass the object into the like rightmost position, like after the of in the for await, and it'll just magically know how to handle it. So I'm going to go over some just examples of ways that you can use it. So Node.js streams are actually async iterators now. So if anyone's tried to do a like concat stream before, it's not too difficult, but it's like a little bit awkward and like a little unclear how to do it unless you go digging through the docs or have done it before. Whereas this is pretty easy. You just like you take a stream and you just loop over the chunks in the stream. You can just push it into an array and buffer concat, and that's it. It's quite easy. So let's get into doing some fun stuff with async iterators. So streams, you'll typically like pipe one stream into another, and do like all sorts of transforms and things like that. So you can do a pretty similar sort of thing with async iterators. Async generator functions, you can just pass in an existing iterator. So the iterator, let's just see. So what I'm using here is this async-iterator-pipe module, which if anyone's familiar with, there's now a pipeline function in Node.js streams, which you can use instead of calling the like stream.pipe. And it just helps with error propagation. It has like an error handler at the end and stuff. So this works in a similar way. You give it a source stream at the start, any number of transforms. In this particular module, you can give it either like a regular stream or an async iterator function, and then eventually there's a target at the end. The the source only needs to be an async iterable, so it could be a stream or just a thing that produces an async iterator, and the rest can be either. So that this function will just take in an iterator and just consume that iterator and produce a new iterator. So this is all you need to do to make an uppercase stream transform, basically. That's fairly trivial and not doing too much interesting. So let's look at something more interesting. So let's write like CSV to JSON, a new line delimited JSON parser. So first you just read the CSV file. You can get a read stream on that. And then this is like a basic line split transform. So again, it takes the iterator. This uses like fairly like unified pattern of it just is a function that takes a single argument, which is the iterator, and like that's sort of the replacement of the pipe idea. So it just allocates an initial empty buffer, and just it'll keep just like appending chunks to this buffer for each chunk that it receives from the iterator given to it. And while there is a new line, character in the current state of the buffer, it will keep trying to slice up to that point and yield that, and then shift the pointer. And at the end, you want to make sure to yield if there's anything left, because you might have like the final line doesn't have a new line character at the end. And then this is transforming. We now have new lines yielded. This is going to take each line and transform that into a CSV format. So the first line that this iterator receives is going to be the key header. So we'll just split the string and then store the keys. And then the next line, we can take those keys and map each value like in the same column to the corresponding key, and then yield that value. And so we have JSON objects now in this iterator, and now we can just JSON stringify them and send them to process standard out. So it makes for somewhat simpler sort of way to do complex types of streams. And so that underlying async iterator-pipe module is actually just this. There's really not much to it. It's this particular function is for consuming a stream. So if you have a stream, then it has the stream write and stream end functions. So you just consume whatever iterator you want to pipe from, and just call the write and end functions on the target. The function, like the async function, like async generator function form, it's even easier. You just call it like a function and give it you call the target function and give it the source. And then there's just a simple switch to identify which type of target it is. And then you can just reduce the chain of targets into the source to get the whole pipeline thing. There's lots of other applications for them. You could make HTTP servers. Instead of having the callback form, you can just have an async iterator of connections, which as always, there's a module for that. There's a module for everything. So you just create an HTTP server, start listening, and then you use http-iterator to wrap the server, and it'll give you an iterator over requests, and then you can just for await over requests, and it has this object that you can destructure both like request and response out of. And this is actually the whole module right here. Uses channel surfer, which provides sort of Go like channels, basically. You just construct a channel, give it an object, remember to close it when you're done with it, and that's it. I'll try to cover a little bit more complicated kind of situation. So like you might have like an API that you want to work with that gives you paginated data, and it's going to give you just this like structured JSON for each page that you have to like navigate through to find the actual items you want. And trying to consume that can be kind of a hassle. So just imagine that this load page is actually like loading from the network somewhere. You're just giving it the page number. So you can create an async iterator over the pages fairly easily. You just have to just keep incrementing the page counter and just await the loaded page. As long as it returns a page, then you can yield the page. But that's still not quite what you want, because that's giving you like each of the page objects. So that the items array, you want the items out of that. So we can just wrap that in another async iterator, which just transforms the pages into yielding each item within the page. And so we can just like do this fairly simple kind of code where we like transform our API into a page iterator and then into an items iterator, and then just loop over all the items. And like in this sort of scenario, if you were, like for example, working with an API that has like throttling or something like that, you could have your load page function have like exponential backoff or something like that, and like all of the downstream stuff would just like not have to care about any of that at all. It'd just get the yielded items whenever it gets them. And so it just makes it super easy to work with a like fairly complex underlying system, but still have like an easy interface to work with. Yeah, so you get pages and turn into items and log them. Another example that's kind of neat is batching. So if you have like a giant sequence of stuff and you don't want to process all of it at once, there's just like a not really super actually interesting example, but this is just an infinite sequence of numbers. So if you want to batch stuff, you're going to need a way to like take a page out of your sequence. So that this is interesting in that it doesn't use for await here, because for await actually will consume the entire iterator, even if you break partway through. So you have to use the iterator interface directly and await each item, check if it's done, and yield the value. And we'll want to turn the like resulting batch into an array eventually. And this looks pretty much identical to the concat function from earlier. It just doesn't do the buffer concat, so you could actually like compose these sorts of things fairly easily. So like rather than having a like specific buffer concat function, you could just have a toArray and hand that into the buffer concat. So it just makes stuff more reusable, I think. And so now that we have the ability to take a page and the ability to turn that page into an array, we can write the batch function itself, which will just loop over, like it'll take a page out of the iterator, turn that into a slice, and as long as there's stuff in that slice, then it'll yield it. And so we can do some like kind of neat stuff here. That's this here is getting like batches of eight numbers, and takes like 10 pages of these batches and then just sums each of them together. It's like you can do fairly like complex scenarios with that sort of thing. So I'll get into some of the pitfalls now. So as I discussed already, there's the issue that for await will fully consume the iterator. So you'll have to use a while loop and use the interface directly for partial consumption. And another issue that is a little complicated to deal with sometimes is that microtasks are actually higher priority in like the event queues in Node than like any of the other types of events. So like IO or like process.nextTick or any of those things. It's possible to create a microtask loop, in which case the process will never actually be able to do anything else. So this right here is we want to create an infinite loop where we have this function that basically takes a task and just awaits and yields whatever the result of that is, and we want to have a timeout. So we don't want it to run forever. After some amount of time, we're going to just set this running flag to false, so that while running eventually stops. And it might seem like this is okay at first, but this actually isn't. And the reason for this is, while it's doing the yield await of a task, that's not necessarily actually async. Well, not necessarily actually something that will be like yield to nodes async. It yields to the microtask async. So the await, if you yield something that is already resolved at the time, it will queue it in the microtask queue. But the microtask queue will just keep going until it's empty. And if you just keep putting more stuff into the microtask queue, then it's never empty and never stops. So we could do something like this. Try and call this function to just produce numbers for like repeatedly for a second, and this will never actually get to the console log at the end, and it'll never actually get to the timeout because it just keeps putting more and more stuff in the microtask queue, and like this can just like totally take down your process if you do this, because it can't ever do IO or anything else because it never gets to that tier of the event loop. Oops. And there's always this fun one. So this is kind of the solution to the previous problem. If anyone remembers the whole like dezalgo thing from the early days, there was a lot of people would write like callback interfaces where they would have like an escape hatch in certain cases. It's like you might have like, for example, like in-memory cache on like a file read. So the first time you read this function, it's going to do like an fs read file. The second time, it's just going to see, oh yeah, I've got this data stuffed in this array, so I'm just going to call the callback immediately. But if you don't put that in like a set immediate or something, you'll get this case where like the function might get called async and might get called sync, and so like the continuing flow of code below that is non-deterministic and just can cause a lot of problems and confusion. So there was a dezalgo module created to basically enforce that things are always async. So this is basically the async iterator equivalent. Just for every item, just make sure that you await a set immediate to basically let it yield to the like node event loop to like move the priority down enough that it can get through I/O and things like that. What about the performance? So lots of people have talked for years and years about performance of promises are slow, but they're not really anymore. Here I'm going to do a bit of a demo. If I can get this to work. Let's see. Yeah, so this is basically running that same like uppercasing stream demo from earlier, and this is running both a stream version and an async iterator version, and this is measuring the like how many bytes per second it's able to transfer. And if you look closely, the async iterator is actually able to send more bytes per second than streams are. Yeah, the uppercasing demo is a somewhat trivial example, though. It's not really doing a whole lot. So I also have the CSV to JSON, which this one, if you look at it, you can't really distinguish the lines. They're close enough that they're basically overlapping. Yeah, so the performance difference between a stream and async generator is basically trivial at this point. So yeah, you can use async iterators now. Just be aware of the pitfalls, and yeah. So.